Bismillahirrahmanirrahim. Assalamualaikum and a very good morning to our respected lecturers. Shukri. My name is Shafika Nabi Hamaswan and today our group will be presenting about car parking ticketing system. So in the second open-ended lab, we use three switches as our input. For the improvement part, at the system output, instead of using only LED and LCD, we also added a servo motor with timer delay and a buzzer. So, three switches input represent three situations, which are when user insert a paid parking ticket, when user insert an unpaid parking ticket, and when they ask the call center for help. So, in the first situation, when user insert a paid parking ticket, the LCD will display thank you and have a nice day, and the LED and servo motor will be turned on, with some delay by using a timer. For the buzzer, there is no changes as it remain off. So in the second situation, if user insert an unpaid parking ticket or there's a problem with the ticket, the LCD will display, please pay your parking ticket and need help, please press switch 3. So the LED will blink and the buzzer will buzz. The servo motor remains off. And for the last situation, as the user requests for help, the LCD will display, please wait for a moment, indicating the waiting process of the operator to help. And the LED will run from left to right and the buzzer will buzz. The servo motor still remains the same. So, by integrating these features, this car parking system is targeted to simplify the vehicle exit process and enhance overall efficiency.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Afzan bin Muhammad Aminuddin. My matric number is 211092009. Today, I would like to present about the objective of the car parking ticket system. For this OEL2, the first objective is to automate and simplify the vehicle exit process in parking lot. Second, to enhance convenience for driver and parking lot operators. Third, to equip students with the ability to create, design, and conduct experiments, collect and interpret the data to solve a problem. And lastly, to equip students with the ability to defend and justify themselves and design a system. That's all for the objective of the car parking ticket system. Thank you.
I will be explaining about the coding that we use for this project. At first, we connect switch 1 to RB0, which is port B, pin 0. And then we connect switch 2 to RB1, which is port B, pin 1. And switch 3 connected to RB2, which is port B, pin 2. For the next one is for the output. For the output is LCD port, which is connected to port D. If you can see here, and LCD register select is connected to RA2, and for the LCD enable we connect to RA3, and for the LCD backlight we connect to RA1. And we also include the buzzer, which is connected to RC2, and last we connect to motor, and it is connected to RA0, which is port A, pin 0. There are other ports that we use, which is, if you can see here, trace B configuration register for port B, used to set input output mode for RB0, RB1 and RB2. Trace A, we can see here, is a configuration register for port A, used to set input or output mode for RA0, RA1, RA2 and RA3. Trace C configuration register for port C, used to set output mode for RC2. Trace D configuration register for port D, used to set output mode for all pins. And lastly is port E, used for controlling LED. So for this case, when the servo motor is open, which indicates the lift up of the gate, we use timer for the delay instead of regular delay.
First of all, let us open our PIXIM Lab spare parts. As you see, this is our input and output. We are in our OEL2, we are using three switches as our input, while LED, LCD, buzzer, and servo motor as our output. The three switches represent three different situations which we usually will face when we wish to exit the car park. When no switch is pressed, the car parking ticketing system will show, please insert your parking ticket. But when the driver insert the parking ticket into the parking system, which is switch 1, when we press switch 1, indicate the situation where the parking ticket are already paid and successfully detected by the machine. At this time, the LCD will display thank you, have a nice day, and the three LED which act as an indicator will light up. The buzzer do not beep, while the servo motor which act as the parking barrier will open 90 degrees for a few seconds, which use timer to allow the car to exit, then close back after the car exit. while switch to, which represent when the driver put the ticket into the exit parking machine to exit the parking ticket, haven't paid, or maybe there's some problem with the ticket, so it unsuccessfully detected by the machine. So at this time, the LCD will display please pay your parking ticket at the first row and need help, press switch 3 at the second row. The 3 LED which act as an indicator will blink to aware the driver and the other driver to allow the other driver notice there is a problem faced by this machine, so other driver can exit by using other exit machine. The buzzer beep based on the blinking of LED, while the servo motor which act as the parking barrier will remain closed, therefore the driver couldn't exit. When switch 3, which represent the driver put in the ticket into the exit parking system to exit, the machine show the parking ticket haven't paid, or maybe there's some problem with the ticket. Therefore, at this time, the driver want to request for help. The driver press switch 3 and the LCD will display please wait for a moment, and followed by the 3 LED which act as an indicator will shows running light for 3 times, which like calling person in charge for help, and the buzzer beep until the running light of LED stop, while the servo motor which act as the parking barrier will remain closed, therefore the driver could not exit and wait for exit.
In conclusion, the car parking ticketing system functions well and achieves the desired objective. The design system is user-friendly and delivers several benefits to both parking operators and drivers, including expediting the ticketing process, boosting space utilization, increasing user convenience, and earning income. In the future, we can advocate integrating the system with digital and mobile payments method to replace all ticketing methods, allowing for seamless and convenient transaction. Integrating mobile payment alternative into the ticketing system allows users to pay for parking using mobile application or digital wallets, removing the needs for paper tickets or cash transaction, and therefore improving the entire user experience. To decrease congestion, we can also use smart parking sensors or camera to monitor and report real-time parking space availability. Drivers can gain access to this information via smartphones, apps, or digital display, allowing them to make informed judgment and rapidly locate available parking spots. That's all from us. Thank you.